Today we have to taken the numericals on electric current through conductors. Here we have taken example: a battery after a long use has an EMF 24 volt and internal resistance 380 ohm. Calculate the maximum current drawn from the battery. And here also we have to ask another question, that is, can this battery drive starting motor of passenger car? First we have to written here given. In this example, we have to given, that is the EMF having the value 24 volt. Therefore, here we have to written here E is equal to 24 volt. That is EMF of battery, which is equal to 24 volt. And internal resistance we have to denote the letter small r. Therefore, this having value 380 ohm. Then we have to ask one question, that is, calculate the maximum current drawn from the battery. Here we have to calculate the value for the maximum current. Therefore, we have to get the formula I maximum, which is equal to EMF of the battery upon an internal resistance. Means I maximum is equal to E upon R. Here we have to substitute the value of the EMF having the value EMF having the value 24 and this R having the value 380. Then we have to divide by this both term, that is 24 and 380, by the term 2. 2 ones are 2, 2 twos are 4, 2 ones are 2, remaining term 1, 2 nines are 18, 2 0 0. Here we have taken 2 6 are 12, 2 8 2 9s are 18, remaining term 1, that is the 5. Hence we have to get the value 6 upon 95. We have to divide it by this 6 upon 95. We have to get the term 0.063 ampere. Means we have to calculate the value for the maximum current drawn from the battery, which is equal to 0.063 ampere. As the value of the current is very small, that is the 0.063, this value is very small compared to the required current to run a starting motor of a car. This battery cannot be used to drive the motor. Means this value cannot be used for drive the starting motor of the car. Here we have taken second example, that is the battery of EMF 12 volt, internal resistance 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, then first we have to calculate resistance of resistor, and another value we have to calculate here, that is calculate terminal voltage of a battery when the circuit is closed. Means here we have to calculate two values. One value we have to calculate here, that is the resistance of a resistor, and another one term we have to calculate, that is the terminal voltage of a battery. First we have to written here value of the battery of EMF, that is the 12 volt, that is E having the value 12 ohm. Internal resistance, which is denoted by the letter R, this value here we have to take here, R is equal to Q. That is the I having value, that is the 0.5 ampere. That is the current having the value 0.5 ampere. Here we have to calculate resistance of a resistor. For this we have to written formula. Formula here we have to taken, that is E is equal to I small r plus I capital R. Means E is equal to this I term, it is the common term, therefore we have written R plus capital R. Here we have to calculate the value for the resistance of resistor. Therefore we have to written here E having the value 12, I having the value 0.5, this R having value 3, plus here we have taken R. Hence for this term we have to divide it by this term of 12 120 upon 5 is equal to 3 plus R. 5 1 is 5, 5 2 is 10, remaining term 2 and 5 4 is 20. Hence we have to get the value 24 which is equal to 3 plus R. Hence 24 minus 3 which is equal to R. Means here we have to get the value 21 is equal to R. Means 21 ohm which is the value for the resistance. Means resistance of resistors which is equal to 21 ohm. Then we have to calculate terminal voltage of a battery when the circuit is closed. Here we have to take the formula, another formula, that is P is equal to I, where V be the terminal potential difference of the cell, I be the current and R be the resistance. Hence P is equal to I having the value 0.5, therefore we have to written here 0.5, R having value 21. Hence we have to get the value, we have to multiply this 21 to the 0.5. We have to get the value 105 and means we have taken this decimal point, that is the P having the value 10.5 volt. That is the terminal potential difference of the battery when the circuit is closed, which is equal to 10.5 volt. Means here we have to calculate resistance of resistance. This resistance of resistor which is equal to 21 ohm and terminal voltage of battery when the circuit is closed which is equal to 10.5 volt. Here we have to discuss another example, that is P resistance. 10 ohm, 20 ohm and 30 ohm are connected in series combination. Find equivalent resistance of series combination. Second thing we have to calculate here, when this series combination is connected to 12 volt supply, by neglecting the value of the internal resistance, obtain potential difference across each resistor. Here first we have to return the given, that is first resistor having the value 10 ohm, therefore R1 is equal to 10 ohm. R2 having the value 20 ohm and third resistance, that is R3 having the value that is 30 ohm. Then we have calculate in series combination, find equivalent resistance of series combination. Here we have to given another term, that is this series combination is connected to 12 volt supply. Means here voltage which is given which is equal to 12 volt. First we have to calculate equivalent resistance of a series combination. In case of equivalent resistance of series combination, we have to take a here, that is RS is equal to R1 plus R2 plus R3. In case of the series combination, we have to add the catalytic resistance, that is RS is equal to R1 plus R2 plus R3. Hence RS is equal to this R1 having the value 10, R2 having the value 20 and this R3 having the value 30. Hence RS is equal to 10 minus 20, that is 30, 30 plus 30 which is equal to 60. That is equivalent resistance of analytic series combination which is equal to that value, then we have to get the value 60 ohm. Then another thing here we have to calculate, when this series combination is connected to 12 volt supply, means this series combination means this 60 ohm is connected to that of the 12 volt supply. Then we have to find out the value, obtain the potential difference across each resistor. For this, here we have to first calculate the value for the current. Therefore, we have to know the formula, that is V is equal to I into R, that is V is equal to I into R. R means series combination. Therefore, we have to written here P is equal to I into RS. Hence, we have to calculate the value for the current. Therefore, we have to written I is equal to P upon the RS. P having the value here 12 volt term, that is 61 60, 16 0, and then we have to take here 2, 62 120, that is 0.22 ampere. Having the value R means current passing through this circuit which is equal to 0.2 ampere. Then we have to calculate the potential difference across each resistor. Each resistance means this 10 ohm we have to calculate the potential difference. For this 20 ohm we have to calculate the potential difference, and for this 30 ohm we have to calculate the potential difference. First we have to take potential difference across R. That is P is equal to I R. That is V1 is equal to I R. Here V1 is equal to I having the value 0.2 and R1 having the value that is 10. Therefore 0.2 into 10, that is the 20. And first we have to take that is the 2 volt. We have taken this decimal point. Then V1 is equal to, we have to get the value 2 volt. Then we have to calculate potential difference across R2, means P2 is equal to R2. R having the value 0.2 into R having R2 having the value 20. Therefore here we have to return 20. That is 20 into 2, that is the 40. That is we have to get the value of this P2 which is equal to 4 volt. Then we have to calculate potential difference across R3. Across R3 means P3 is equal to I into R3, means P3 is equal to I having the value this 0.2, R3 having the value 30, therefore 0.2 into 30, hence P3 is equal to 30 into 2, that is 60, that is 6.0 volt. Means here we have to calculate the value for the potential difference across each resistance, that is for the resistance R1 we have to calculate the voltage, that is the V1 is equal to 2 volt. For this resistance also R2 potential difference which is equal to 4 volt, and for this resistance R3 we have to get the value 6 volt. Means here we have to get the equivalent resistance, that is equivalent resistance of series combination which is equal to 60 ohm, and potential difference across each resistance which is equal to 2 volt, 4 volt and 6 volt. In this way we have to solve this example. Two resistance 1 kilo ohm and 2 kilo ohm are connected in parallel combination. First we have to calculate, find equivalent resistance of parallel combination. Second thing, here we have to calculate when this parallel combination is connected to 9 volt supply by neglecting the internal resistance, calculate current through each resistance. First here we have to take the term, that is the given term, that is here given. We have to give first resistance having the value 1 kilo ohm, that is R1 having the value 1 kilo ohm, R2 having the value 2 kilo ohm, which are connected in parallel combination, and we have to calculate equivalent resistance of parallel combination. Then we have to calculate when this parallel combination is connected to 9 volt, that is here we have to take the voltage, that is the 9 volt. First here we have to calculate equivalent resistance of parallel combination. In case of parallel combination, we have to see the formula, that is 1 upon Rp, which is equal to 1 upon R1 plus 1 upon R2. This is the formula for calculating equivalent resistance of parallel combination. Means 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. Hence 1 upon Rp, which is equal to R2 R1 upon R1 into R2. This we have to take a cross multiplication here. Hence 1 upon R2 is equal to R2 plus R1 upon R1 into R2. We have to calculate the value for this R2. Therefore we have to take here reciprocal. Hence we have to get value R1 R2 upon R1 plus R2. Means we have to get the formula for calculate the equivalent resistance in parallel combination, that is Rp is equal to R1 into R2. R1 having the value 1 kilo ohm. Here we have to substitute the value of the R1. Here R2 having the value 2 kilo ohm. Here we have to substitute the value R2 upon R1 plus R2. Means here we have taken 1 plus 2. Means here we have seen that Rp is equal to 2 1 are 2 upon 2 1 plus 1. That is we have to get the value 2 upon 3. Hence Rp is equal to, we have to divide it by this term of 3 to the capital that is 2. Hence we have to get the value 0. We have to take here 0. 3 6 are 18. Remaining term of 2. That is here we have taken 0.666. Therefore here we have to calculate the value of the current, which is equal to 0.66 kilo ohm. That is in parallel combination. That is equivalent resistance of parallel combination, which is equal to 0.66 kilo ohm. Then we have to calculate the internal. Then we have to calculate current through each resistor. Therefore we have to see the formula for calculating the current, that is P is equal to IR. Means when we have to calculate the value of R, we have to take the formula in this way, that is P upon R. Means P upon R is equal to I. Here we have to calculate the value for the current. For this first resistance, therefore we have taken here I1, resistance having value R1, and we have to calculate the value for the current. Here P having the value 9 volt, R1 having the value 1, which is equal to I1. Means 9 upon 10 raised to 3, which is equal to I1. Means from this 1 kilo ohm, we have to convert this 1 kilo ohm into ohm, that is 10 raised to 3 ohm. And this 2 kilo ohm, we have to calculate in this way, 2 into 10 raised to 3 ohm. Therefore we have to divide it by this 9 upon 10 raised to 3 is equal to I1. Hence 9 into 10 raised to minus 3 is equal to I1, or can I 0.009 ampere current, which is passing through the resistance R1 having the value 1 kilo ohm. Means here we have taken here 9 into 10 raised to minus 3 or 0.009, which is equal to can I taken in this 9 into 10 raised to minus 3 ampere, which is equal to I1. In this way we also written 0.09. Then we have to calculate the current for the resistance 2 kilo ohm. Hence here we have to written formula P upon R2, which is equal to I2. This P having the value 9 upon R2 having value 2 into 10 raised to 3, which is equal to I2. Hence from this 2 we have to divide it by this 9. Therefore we have to written here 4.5. Means we have to write the value 4.5 into 10 raised to minus 3 I2. Means we have to get the value 4.5 into 10 raised to minus 3 ampere, which is equal to I2. Or here we have to written 4.5 milliampere, which is equal to I2. Means here also we have to written in this way also, that is the 9 milliampere, which is equal to I1. Means here we have to get the two values for this current. That is, first we have to calculate equivalent resistance of parallel combination, which is equal to 0.66 kilo ohm current flowing through the 1 kilo ohm and 2 kilo ohm resistance are 9 milliampere and 4.5 milliampere. Means here we have taken 4.5 milliampere current passing through each resistor. Last example, here we have to see here, that is a silver wire has a resistance of 4.2 ohm at 27 degree centigrade and resistance 5.4 ohm at 100 degree centigrade. Determine the temperature coefficient of resistance. First, here we have to take the term given. This given term, the silver wire has a resistance of 4.2 ohm, means initial resistance of the wire, that is the R1, which is equal to 4.2 ohm. When the resistance is 4.2 ohm at this temperature T1, which is equal to 27 degree centigrade, means temperature किती झालं 27 degree centigrade and resistance किती झालं 4.2 ohm, and resistance for that is काय सांगितलंय final resistance, that is R2, which is equal to 5.4 ohm, and this value temperature T2, which is equal to 100 degree centigrade. Here we have to calculate the temperature coefficient of resistance, means here we have to calculate value for the alpha, this alpha which is the useful for the temperature coefficient of resistance. Then we have to take a formula for this alpha, that is alpha is equal to, we have to see here, alpha means the temperature coefficient of resistance. This temperature coefficient of resistance we have to calculate here. Alpha is equal to R2 minus R1 upon R1 in bracket T2 minus T1. Hence, we have to substitute in the value for the R2. R2 having the value 5.4, R1 having the value 4.2. Here this R1 also having the value 4.2. This T2 having the value 100 minus this T1 having the value 27 degree centigrade. Means here we have to substitute the value of the R2, R1 and T2 minus T1. Hence, alpha is equal to, then we have to mathematically subtract 5.4 minus 4.2. Here 4 minus 2, that is the 2, and 5 minus 4, that is the 1. Here we have to get the value 1.2. This is the term of 4.2, and 100 minus 27. When we have to multiply, when we have to subtract from this 100 minus 27, we have to get the value 73. Then we have to take this term in this way, that is the 12 upon 42. Means we have to calculate the decimal fraction. Convert 1.2 on 4.2, one decimal point. Therefore, we have to written here alpha is equal to 12 upon 42 into 73. Hence, alpha is equal to, we have to divide by this 12 and 42 by term of 2. 2 6 are 12, 2 2s are 4, 2 1s are 2. Therefore, we have to get the value 6 upon 21 into 73. Hence, alpha is equal to 6 upon 23 is multiplied by this 21. That is the here we have to take here. That is the 21 3s are 63. Therefore, 3 27s are, that is 147. We have to add in this term 7 plus 6. That is the 13. 4 plus 1 5. 153. That is we have to take the value 1533. Hence, this alpha is equal to, we have to given here term 6 upon 1533. Then we have to get the value, this value, that is 3.91 into 10 raised to minus 3 per degree centigrade. That is we have to get the value 3.91 into 10 raised to minus 3. Means here we have to calculate the temperature coefficient of a resistance in this way. Here we have to see some examples in electric current through the conductor.